SolidWorks Simulation Lecture 1, the structure of CA analysis. First of all, we open a part file in SolidWorks and on XY plane enter sketch mode and draw a rectangle. And I'm not going to place any dimension on it to simplify your procedure so that you can concentrate on the CAE part. So I'll extrude it to a certain distance, and this is a brick or block that I need, and I'll save the file on desktop. There are 3 preparation steps for CAE analysis. The first one is loading the software, add in, or tool, add in. And you can do it here, the fast drop-down menu, add in, and choose the software, SolidWorks Simulation. And then the second preparation step is to load the toolbar. Right-click the mouse on the toolbar area and choose Simulation. And this is the toolbar. Okay. Now you can open a static study. Now, actually, this is the first step of the CA analysis, which is drawing over 3D model and open a study. But there is still a third preparation step, which is to organize the toolbars. For example, this is a static analysis, and then this is step 1. Step 2 is material. Step 3 is meshing, and step 4 is boundary condition and loading. Step 5 is running the procedure, and step 6 the result. If the icons here is not like this, you have to arrange the toolbar, and you can do it here in the first drop-down menu, customize, or tool, customize. And I always do it here in the first drop-down menu, customize. And in commands, you choose simulation, simulation, and you can drag these tools or icons. For example, the restraints or constraint tool, and you drag and drop it here. And also the concentrated force, I can drag and drop it here, so that the toolbar is like 1, 2, 3, 4, 5, 6. So this is how we facilitate our simulation process. Now we can begin with the CA simulation. In the CA analysis, there are 6 steps. The first step is drawing a 3D model and open a study. The second is defining the material, and I can choose ARSI 1020 low carbon steel and apply on the geometry. You have to make sure that the materials is linked to the part, to the geometry, so that we have finished with the first and second step. The first is geometry and open a case, and the second is material. The third is meshing, and this is a mesh. I'll hide the mesh because the mesh is only used for calculation in the computer. The fourth step, the first part is constraint. I'll fix this end, this surface, and then the second part is loading. I'll exert a force, a concentrated force on the top surface, and this is the area on which the force is applied. And for the direction of the force, I can choose direction or normal force. Now I'll choose direction so that I can choose this line to indicate the direction of the force, and I can toggle the direction on which the force will apply. So this is the direction of the force. And for magnitude of the force, I'll give it 100 Newton. So there are 3 parts in the force application. The first part is the surface of the force. The second is the direction of the force, and the third is the magnitude of the force. Once we reach step 4, and we have finished with the definition of the whole problem, and the 4 steps here are called preprocesses, including 3D geometry, material, mesh, boundary condition, and loading. So now the problem is totally defined, so we can proceed with the calculation part. And this is the step 5. And step 6 will be the result. For example, we can double click on the displacement or right click on the stress to show the plots. And we can also play the animate, and we can make it play faster or slower. We can also make it smoother. This is how many number of frames per second. So it is smoother with larger number of frames per second. And we can also probe the numerical values of the result. And now we can also draw a curve for the probe data, and also we can save it on the desktop and then process it with Excel, so we can make a better curve, a better looking curve. For example, in the Excel, you can even manipulate with some of the data if you really want to. And so now we have a probing function, and also the most important function in CAE simulation is that you've got a report function. So it writes a report for you, the whole report for the simulation. And you can get Chinese, English reports, or even maybe Indonesian or any other languages that you use, and the language will be defined in the software. So you can generate English report, Chinese report, Indonesian report, like that. Oh, okay, so this is very convenient things to do. There are also a lot of post-processor functions, and I'm not going to get into it right now. So this is the first lecture, which is very important. The sixth step for CAE analysis applies to all CAE softwares all over the world, including ANSYS, Nastran, COMSOL, and of course for SolidWorks simulation or Cosmos. So you have to be very familiar with these steps. The sixth step including the geometry, material, meshing, boundary condition, and loading, running, and the result. So this is the lecture 1 of SolidWorks simulation.